test. Mic test. 1, 2, 3, check. Mic check. 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 Good evening, ladies and gentlemen. A very warm welcome to the ICI Ultratech Awards 2022. So our guests, there are many more guests to arrive. So till then, we are going to entertain you with a musical extravaganza. So we have with us a very talented, very experienced musician who is a violinist and a singer and an expert in many other instruments as well. Please welcome on stage Rinesh Narayan. ഒരു കയ്യടിയൊക്കെ ആവാം നമ്മൾ കുറച്ച് പേരെല്ലെങ്കിലും ഉള്ളവരെ വെച്ചിട്ട് let us appreciate our musicians. We are going to have a beautiful musical extravaganza this evening. So enjoy this evening, ladies and gentlemen. Thank you.
Oh
Wasn't that a lovely performance by Ranish? Can we give him a bigger appreciation, a bigger round of applause? Thank you, Ranish, for entertaining us with that beautiful violin performance. Now we are going to have a vocal performance by our next artist, that is Shinu Chandran. Let us welcome him on stage with a big round of applause. Can't hear the claps, yes.
Hello.
Thank you, thank you.
കേരനിരകളാടും ഒരു ഹരിത ചാരുതീരം പുഴയോരം കളമേളം കവിത പാടും തീരം കായലലകൾ പുൽകും കനുവലിയുമീറൻ കാറ്റിൽ ഇരഞ്ഞാറിൻ നിലയാകും കുളിരുലാവും നാട് നിറപ്പൊലിയേകാമെന്നരിയ നേരിനായി പുതുവിഴ നേരുന്നോരിനെയെന്നാടിതാ പാടാൻ കുട്ടനാടിൻ നീളം കേരനിരകളാടും ഒരു ഹരിത ചാരുതീരം പുഴയോരം കളമേളം കവിത പാടും തീരം കണ്ണോടു കരിയൊഴും മണ്ണുതിരും മണമോ പെണ്ണിനു വിയർപ്പാലേ മധുമണമോ ഞാറ്റോല പച്ചവര പൊന്നും തെളിക്കൊലുസ പെണ്ണിവൾ കളമാറ്റും കളമൊഴിയായി കൊറ്റികൾ പകിളെ നിലാക്കാടും മൊട്ടിടുമനുരാഗക്കരൾ പോലെ മണ്ണിനും ഇവൾ പോലെ മനം തുടിക്കും പാടാൻ കുട്ടനാടിൻ നീളം കേരനിരകളാടും ഒരു ഹരിത ചാരുതീരം പുഴയോരം കളമേളം കവിത പാടും തീരം പൊന്നാര്യൻ കതിരിടും സ്വർണമണി നിറമോ കണ്ണിനു കണിയാകും നിറ പറയോ പെണ്ണാള് കൊയ്തുവരും കറ്റ നിറ പൊലിയാ നെല്ലറ നിറയേണം മനസ്സു പോലെ ഉത്സവത്തൊടി താളക്കൊടിയേറ്റം മത്സര കളിവള്ളത്തിരയോട്ടം പെണ്ണിനു മനമാകെ മയിലാട്ടം പാടാം കുട്ടനാടിൻ നീളം കേരനിരകളാടും ഒരു ഹരിത ചാരുതീരം പുഴയോരം കളമേളം പാടും തീരം ആയലകൾ പുൽകും കണുവലിയുമീറൻ കാറ്റിൽ നിറഞ്ഞാഴിൻ നിഴലാകും കുളിരുലാകും നാട് നിറപൊലിയേകാമെന്നരിയ നേരിനായി പുതുവിഴ നേരുന്നോരിനെയും നാടിതാ പാടാ കുട്ടനാടിൻ നീളം കേരനിരകളാടും ഒരു ഹരിത ചാരുതീരം പുഴയോരം കളമേളം കവിത പാടും തീരം Thank you.
Beautiful, Ranish, really beautiful. So we've been seeing Ranish playing alone in the violin, and we've been seeing Shinu singing individually. Now both of them are going to combine and have a violin cum vocal performance. Are you ready to see that? They make a really beautiful combination. So here is Ranish Narayan and Shinu Chandran.
மலரே மௌனமா மௌனமே வேதமா பாதி ஜீவன் கொண்டு தேகம் வாழ்ந்து வந்ததோ ஏதோ சுகம் உள்ளூருதே ஏதோ சுகம் உள்ளூருதே விரல்கள் தொடவா மார்போடு கண்கள் மூடவா மலரே மௌனமா காற்றை போல வந்து கண்கள் மெல்ல திறந்தே பூவின் என்னை தள்ளாதிரு பூவே என்னை தள்ளாதிரு உயிரின் உயிரே மலரே மௌனமா மௌனமே வேதமா
Thank you.
Thank you.
Thank you so much, Ranish. And now we are beginning our program, requesting all our guests who are outside to kindly come and be seated. We are going to begin our program right now, requesting everyone to settle down and be seated. Thank you. Ladies and gentlemen, we are going to begin the ICI Ultratech Awards 2022, requesting all our esteemed guests to kindly take your seats and enjoy the program. Thank you. I can see our guests settling down, but there are many unoccupied chairs in the front itself. Instead of our esteemed guests sitting in the back, avada backil irikkunenu pagaram ivide munnil orupaadu vacant aayittulla kaseeragal undu munnil vannirikkam. So, good evening, ladies and gentlemen. I'm Anita, your master of ceremony for this program, and on behalf of the Indian Concrete Institute, Kochi Center, and Ultratech Cement Limited, a very warm welcome to the Concrete Day celebrations and the ICI Ultratech Awards 2022. Let us begin our celebrations with a big round of applause. Come on, everyone. Yes, let us get the energy set for this event. So here is a beautiful gathering, a beautiful union, a beautiful gathering of all the stakeholders of the cement and concrete industry, joined together on one side by the Indian Concrete Institute, a strong professional body with more than 13,000 members all across India, and on the other side by Ultratech Cement Limited, the largest manufacturers of cement in India. And today we are going to have our celebration in two phases. So in the first phase, we are going to have the Concrete Day lecture, which is going to be given by an eminent personality from the concrete industry, after which we are going to move on to our much-awaited ICI Ultratech Awards. So, ladies and gentlemen, are you ready to begin the celebrations? Yes? I need a spirited yes so that we can kickstart this beautiful evening. Are you ready to begin the celebrations at ICI Ultratech Awards? Okay, lovely. So without much ado, let us begin our program. Let us begin by invoking the blessings of God Almighty. We have the Aditya Vandanam, which is a reflection of our values and our commitment towards a never-ending journey towards excellence. So let us begin our program with the auspicious Aditya Vandanam. We do have some music.
आदित्यः सविता सूर्यः खगः भूषा गभस्तिमान् सुवर्णसदृशो भानुर्विश्वतो ईश्वरेता दिवाकरः तच्चामि कराभाय हरये विश्वकर्मणे नमस्तमो विनिघ्नाय पूजये लोकसाक्षिणे जयाय जयभद्राय हर्षवाय नमो नमः सहस्रांश आदित्याय नमो नमः आदित्याय नमो नमः
That, ladies and gentlemen, is the Aditya Vandanam. So let our journey be filled with victory. And now it is time to begin the official program. First and foremost, with a big round of applause, let us invite on stage the chairman of Indian Concrete Institute Kochi Center, Dr. Anil Joseph, requesting Dr. Anil Joseph to welcome this august gathering.
Yeah. Good evening, all. Indeed, it's a great pleasure and privilege for me to welcome this August gathering. For today, we are having a celebrations happening. We are celebrating the success of completion of our dreams. Our house is always a dream. And you have, with the concrete, cement and steel, made it happen. It was being scrutinized by an eminent list of juries who has gone into that and found that your house or apartment or the construction, the effort you have put in needs a huge round of applause. So let us begin by applauding all the people who is going to win the awards today. Concrete, and we always say it's a concrete move. So we believe concrete is strength. Everything connected with concrete is strength. Power and energy is shown in that. And it's a great pleasure for Indian Concrete Institute to associate with the leading cement manufacturing company called Ultratech to bring out this. I was always proud of Ultratech from the days when Ultratech came with the slogan, the engineer's choice. After they took over the L&D cements, and maybe 10 or 15 years before, I was driving down the road and I saw this board, Ultratech Cement, the engineer's choice. It's very rarely the engineers get recognized, the buildings get recognized, and this is an occasion where we come together to celebrate our victory. ICI, we are going to see what it's all about. We are a group of professionals, a body who is in the field of concrete and who love our concrete. And concrete is beautiful because it's so unpredictable. And it is like making your food. The cement can be the best, but a little bit of water ratio going up can spoil it quite badly. Today, we have an eminent team. People are ready to receive the award, and my duty is to welcome all of you to this August gathering. We have an eminent speaker today, our Professor KVL Subramaniam from IIT Hyderabad, who is a specialist in concrete technology, and he is going to tell us what is the type of concrete you need for 3D printing, which is the future. So our worry of concrete based on water and other aspects will get away moment it can become robotic, and the technology which KVL Subramanian sir is going to share us can bring concrete without the man element and the uncertainty. Yes, this is the era of artificial intelligence and machine learning, and we have to adopt that into our concrete manufacturing also, which will be the future. I am very proud to welcome the dignitaries from Ultratech Cement, who are the main sponsor of the event. Engineer Punnus John, the zonal head technical. Welcome, sir. Mr. Annie George, Regional Head Marketing. Engineer Jayashankar K, Head Marketing. BPD, UBS and Digital Innovation. So your designation has changed to a higher level. And that exactly was I talking about. The digital innovations is going to rock concrete in the future. We are going to have self-scaling concrete, self-compacting concrete, and automated concrete in the near future. You just have to press some button and everything will be done. And that we will hear quite soon. And we have our own member, the dynamic personality, Sajid Bhaskar, who is conducting this program. I would like the audience to give a special round of applause for Sajid Bhaskar, who has done celebrating your victory, your efforts, your products are being recognized in this platform. May I also take the opportunity to welcome my beloved committee members, the Vice Chairman, Elson John, our Secretary, Dr. Job Thomas, and there is a list of luminaries who are here. And also I would like to take this opportunity to welcome the first chairman of ICI Kochi, the man who made Kochi chapter the best chapter.
Aishwaryamai Bhadradibam Telicha, let us mark the beginning to ICI Ultratech Awards 2022. Ladies and gentlemen, let us give a big round of applause as we do the honors of lighting the ceremonial lamp.
Of BIS. Focused towards advocating the concept of sustainability in construction practices, ICI is participating actively in the Asian Concrete Federation, a group of professional bodies of 10 Asian countries. ICI has signed MOUs with many other concrete institutes around the world for exchange of technological information, technical documents, and to organize programs jointly. Keeping the ever-changing future in perspective, ICI reaches to budding civil engineers through students' chapters. There are more than 165 students' chapters all over the country, and the numbers are constantly increasing. Each chapter is focused on bridging the gap between basic theoretical knowledge and professional practice by imparting requisite knowledge to budding engineers. ICI identifies, recognizes, and awards the experts in the field of concrete for their contributions to the development of concrete technology and concrete construction. Every year, 16 such awards are presented at the time of AGM. To disseminate knowledge, ICI brings out several publications with the help of technical committees for the benefit of practicing technocrats. Its journal is of national repute today. Very soon, a journal of international standards will be brought out in collaboration with a world-renowned publisher. Every dawn at ICI summons a new approach and new initiatives to create milestones in the journey of concrete construction in India. ICI has enabled the multifaceted and rapid development of concrete construction in a well-planned manner. It stands proud today with a distinguished reputation as a forerunner and a binding force in civil engineering industry in India. Come, join and strengthen ICI. Let us make our concrete structures sustainable, durable, and best in the world.
So that, ladies and gentlemen, is the great Indian Concrete Institute, bringing together engineers, architects, consultants, researchers, academicians, manufacturers, designers, people, all stakeholders from the cement and concrete industry. and not only spreading its wings nationally, but also having associations with international bodies as well, a really proud organization to be associated with. And now, ICI Kochi Center is one of the most active centers, and to know more about ICI Kochi and its activities, I call upon Engineer Shaiju Nair, the Treasurer of ICI Kochi, to present the activities of ICI Kochi Center. Ladies and gentlemen, please welcome Engineer Shaiju Nair.
A very warm good evening to one and all. So we have already gone through a detailed corporate video. So my duty is actually very limited. So let me give a brief about ICI Kochi Center. ICI Kochi Center was initiated on 25th February 2010 and very soon named as the best emerging center at national level. We were very lucky to have efficient leadership team for our ICI Kochi Center from beginning. ICI Kochi has been consistently conducting various programs like seminars, conferences, workshops, exhibitions, etc. throughout the year, attracting active involvement and promoting a large number of professionals in the construction and infrastructure industry. ICI Kochi has also partnered with GRACE, Structural Engineers Association, ACE and Lensword for various events in Kochi. Now, under the leadership of our chairman, Dr. Anil Joseph sir, this year also we conducted industrial visits, seminars, project visits, online webinars, etc. for students and professionals. Every month, we used to have at least one offline and one online program. Currently, we have 20 students chapters, and we were very keen in bridging the gap between academics and industry. So we are planning and we are also doing so many programs for these students chapters. We are planning to have a calendar of activities in place for students chapter. Also, we are planning to give special training to students for their empowerment. We have a strength of 266 members and still it is growing. So this is a small brief about ICI Kochi chapter. Thank you.
Thank you so much, Engineer Shaiju, for that description of the ICI Kochi Center activities. Very happy to know that you're bridging the gap between the student community and the engineers. 20 student chapters is quite a big number, and you have quite a lot of members also. Now I can see why ICI Kochi is a very active center in Kerala. Now, ladies and gentlemen, we are coming to the first part of our celebrations, that is the Concrete Day lecture, which is on improvements in concrete processing leading to 3D concrete printing by Professor KVL Subramanian of IIT Hyderabad. And to introduce our keynote speaker, I invite Dr. Elson John, the Vice Chairman of ICI Kochi Center. Ladies and gentlemen, please put your hands together for Dr. Elson John, the Vice Chairman of ICI Kochi Center.
Scientists study the world as it is. Engineers create the world that never has been. A very warm good evening to all of you. Today, the Indian Concrete Institute joins hands with Ultratech Cement to honor the veterans and young budding engineers and students in the field of engineering and concrete technology. ICI is dedicated to the cause of disseminating knowledge about the concrete for the betterment of the concrete technology and quality construction. ICI starts its journey in Cochin in the year 2010, and since then there is no looking back, and ICI has grown in leaps and bounds. We would like to thank all the technocrats and well-wishers for this same. Let me switch on to my responsibility. If one takes a closer look at the alchemy of an achieving person, two distinct virtues pop up, besides perseverance and hard work. These are the pioneering spirit and willingness. Today, we are very privileged to have our guest, an incarnation of a successful teacher and an engineer. It is none other than Professor KVL Subramaniam. He is presently the professor at IIT Hyderabad and Dean Planning and Development, who is look over the construction activities of IIT Hyderabad. Prior to joining IIT Hyderabad, he was a professor at Cattle Research Fellow in Department of Civil Engineering at the Groove School of Engineering, the City College of New York. Dr. Subramaniam obtained his BTech from IIT Delhi and PhD from Northwestern University, USA. Dr. Subramaniam was awarded the earlier Career Award from National Service Foundation of USA. He received the James Instrument Award from American Concrete Institute in 1999 for his research in non-destructive testing of concrete. He was the chairman Committee 215 on Fatigue of Concrete of ACI. In 2009, he was elected as Fellow of American Concrete Institute for notable contributions in the area of concrete technology. He is an associate editor of Journal of Materials in Civil Engineering of ASCE. He is on the editorial board of Journal of Cement and Concrete Composites. He is a life member of ICI, and he was elected as the Fellow of Indian National Academy of Engineering in 2021. His achievements and contributions are goes on. So as Anil sir was telling, Sajit is looking at me, so I am just stopping this. Today, he is going to deliver a talk, a very important and latest trend in the area of concrete technology, improvement in concrete processing, leading to 3D concrete printing. With this, I am winding up. Thank you.
Ladies and gentlemen, please put your hands together and welcome Professor KVL Subramanian from IIT Hyderabad to deliver the technical presentation, the Concrete Day lecture for today. Yes, it's an absolute honor to have the presence of Professor KVL Subramaniam. Thank you so much, sir, for taking your time out and coming all the way to Kochi to deliver this presentation.
Good evening, and first of all, I'd like to thank the local chapter, the ICI, Kochi Center, for inviting me here, Ultratech Cements for organizing this wonderful event, for backing up this event, and giving me a chance to present something that is quite close to my heart, that is concrete technology, new developments in concrete materials, and the advances in materials that are taking place, especially in concrete. Now, I'll start off by saying something provocative. This was about 12, 13 years back. ACI, the American Concrete Institute, really wanted to stir the pot. They wanted to get some excitement. And so they organized a whole session which was titled in a rather provocative manner, where they said, "It is not your father's concrete anymore." And the whole idea was to get people excited about concrete and all the new developments that are taking place in concrete. Because otherwise, it's treated like a pedestrian material that you take for granted. It is something that people believe is everywhere, but they don't realize the value of the material and the fact that this is the material of the future. So let me just start off with this talk, first of all, by showing this graph. This is the skyline as it has changed, and if you look at this like a graph, starting from 1930s, which is the Empire State Building on your left, all the way to Burj Khalifa, the tallest building. But what is more notable is that if you look at somewhere around Taipei 101, to the left of that, you see that concrete started emerging into the structural systems. And you start seeing that concrete is occupying a more and more prominent role in the structural systems, even in the super talls. And that has happened because of advances that have taken place in concrete that has allowed it to displace steel as the primary choice of construction material, particularly for super tall material. So we're able to engineer the material, and the material offers us the opportunity to do so. Now, here's some more statistics for you. If you look at the super tall buildings, and if you look at the 100 tallest buildings in the world today, about 59 of them are in Asia, South Asia. 23 are in Middle East, and that only leaves about 18 in the rest of the world. So in the world of super talls, most of the action is happening in Asia, South Asia. And if you look at this choice material for construction of these, and if I take benchmark of Burj Khalifa and the 1 kilometer tall tower that's coming up in Saudi Arabia, the structural system is concrete. That means that we have made progress with the material to the point that it is being used as a structural material for structural framing in these super tall buildings. There's some more information for you that if you look at this bar chart, starting from the 1930s all the way up to 2018, 1930s, the talls and the super talls were primarily steel structural systems. As you start sliding towards 2000s, you start seeing the share of the steels decrease, the share of concrete starts to increase. Now, whether it is concrete used solo or concrete used with steel as composite construction, it is to the point now that 63% of the constructed super talls after 2000 were primarily made or had concrete structural systems. And this is because we have been able to make concrete of the strength we desire. Now we're able to compete. We're able to produce very strong concretes. We're able to deliver on the technology. So now we can actually, and I'll present this in the next few slides, we have technology that allows us to deliver concrete to a height of 1 kilometer. And we have pumping systems that are available. So technology is advanced. Construction techniques have advanced that allow us to build faster. And best of all, it's still affordable compared to other construction materials. So we can deliver the volumes that are required at a low cost. So that is what makes it the enduring and endearing choice of material for construction. So this is the overall background when it comes to concrete technology. And what about concrete itself? How much of this material are we producing? Of course, I'll be preaching to the choir here, but it's almost 2 tons per year for every human being on the planet. So in terms of volume of the material, it is enormous. So there is no other material that we can produce in this quantity. And part of it has to do with abundant availability of the material that we use to make concrete and the cost. So far, it is still the least or probably the lowest in terms of cost when it comes to construction materials. But there is something that we need to be wary of. If you look at this graph here, this is how cement production has scaled over the years. So this is the graph of cement production. And what you see is starting from 1990s, you follow the colors, they're actually aptly coded. The red stands for China, blue is India, and yellow is all the other developing countries, and the light blue is all the industrialized or the so-called advanced countries. Now, if you look at it, China, the cement production peaked around, I'd say it's peaking right now, and the production of, the requirement of cement in China is going to decrease over the time. India, we are just about sitting on the cusp of our development. We are going to pump money into infrastructure, which we already are, and all that infrastructure needs concrete, for which we need cement. And if you look at the projected numbers, we need a lot of cement, and that is going to become a very large challenge for us. Now, we will be forced to develop our infrastructure with one hand tied behind our back, because there are all kinds of environmental tags that are being put on the production of cement, which means that we have to be very judicious with the use of cement. We still have to produce the infrastructure, because without that infrastructure, there is no possibility that we'll be growing at the rate at which we want to grow. There's no way that it will become a $5 trillion economy. So investments have to be made in infrastructure. We need the infrastructure. We have to produce it, but in a way that uses material more efficiently. And one of the biggest challenges that we have with cement production, or there are actually 3 challenges there, is cement. If you look at 2050, the projected numbers, of course, these are projected numbers. If you look at or consider a model that we call business as usual model, that is, we continue growing, producing cement the way we are today, then we would require 750 million tons per annum to meet our demand. That is the projected numbers. Of course, these are projections, but that is a very large quantity of cement that we would need. And the problem, there are three problems currently that we face with cement. First thing is the available limestone. So far, we've been blessed with very good limestone that goes into making cement. And so we've been producing cement quite happily because we have very good grade limestone. But the best grade limestones, if you look at the projected scenario, are expected to last for another 35, 40 years. What after that? Energy requirements. Cement production, while it is not the most energy intensive material, still requires a lot of energy. So we need to look for energy sources to produce the cement and the carbon footprint. This has become the biggest killer of cement production, or one of the silent killers of cement production, where it's being tagged with a carbon tag. And today, if you look at anthropogenic sources of carbon dioxide, the human-made sources of carbon dioxide, cement production ranks second or third, depending on which source you take for information. So this is something that is being tagged onto cement, and we need to find alternate solutions. So if you look at the number one source, automobiles, they're already, or power generation, they're already looking for alternates. So cement has to look for alternates, and the solutions are already on the way. And this is one area where I believe India has taken the lead. I think we have now done several things. One, our cement production over the years has become very, very efficient. The cement plants in India are run at very high efficiency and perhaps compete with the best in the world when it comes to efficiency in production, in terms of energy, in terms of material usage. The other thing we've been starting to do is look at the carbon intensive material in cement, which is the clinker. And we are looking at reduction of the clinker factor in cement. And India has pushed aggressively forward in replacement of cement with other materials, waste materials like fly ash and slags, and these have become commercially available. So PPC and PSC, these have become readily available, commercially adopted, and are being used for construction. I think on this regard, we are moving forward quite well. In addition to that, we are looking at other products that are coming into the market, like the LC3 cements and their alkali activated binders. So these are all new materials that are going to come, and probably in the next decade or so, you will see commercial usage of these materials. So this is the background about the cement, concrete, the requirement and our demand in the next few years. Now, in terms of construction, what are the challenges that we have in construction? One of the biggest issues with concrete construction has always been the speed of construction. Everybody demands faster construction, and one of the biggest stumbling blocks with building faster is that we are currently limited to forming on site. That is an advantage because I can form concrete on site, but it also becomes a disadvantage because the formwork cycle times dictate the speed with which I can construct. How fast can I assemble my formwork? How fast can I tie the steel? That dictates how fast I can construct the structure. Filling and placement of concrete also becomes a very important parameter. How fast can I fill, place concrete, compact it properly? It is the quality of the concrete that determines the performance of the structure over the long term. So these have now become our stumbling blocks, and therefore research is being done into these specific aspects. And this is where the new technology is coming out. The real demand for 3D printing is coming, adopting digital techniques of concrete construction is coming from these requirements. Can I build faster? Can I use less material, go into lean construction? And three is, can I actually develop delivery systems that free me up from the conventional systems, the way I place concrete, the way I compact concrete. The other thing is with concrete, we are limited to rectilinear shapes. That is, everything we do is typically rectangular in shape. And the reason is it's easy to form on site. So our beams are typically rectangular. We don't have beams that are I-shaped or T-shaped or any other shape unless they are precast. When they're cast on site, typically we have only rectangular beams. And that limits us in terms of material usage. Rectangular beams are not the most efficient structural systems or structural forms that are available. We add a lot of material, which adds weight. We use up material, whereas in terms of performance, an I-beam perhaps is structurally as efficient as a rectangular beam, where I use less material to deliver the same performance. The problem is forming on site. So can I develop construction techniques that allow me to deliver different shapes? And what if I want to develop a shape like this, what is shown there? Can I do this on site? With the current construction techniques, I cannot. What if I do all my optimization and figure out that the structural shape I need is not rectilinear. It is actually curvilinear. Then what do I do? So that means I have to have advances in construction technology that allow me to produce a shape like that on site, where I should be able to go to the site and make the structure the shape that I want. So that requires tremendous amount of advancement in technology, in material technology, in processing technology, and also in placement technology. So all three of these have to advance concurrently for us to deliver on that promise. So concrete construction of future, as we are talking about, what we want to do is make concrete responsive to the requirement. That is, we want to tailor the delivery and placement. We want to make concrete behave the way we want in the fresh state, so we can place it the way we want. And of course also ensure performance and service. That means once I build a structure, I get assured performance over a certain period of time, which basically leads to this whole design of long-lasting structures which don't have to be replaced often. Now, along those lines now, where we are moving is into this whole paradigm of performance-based design. Now, this is different from the conventional way that we've been doing things. The way conventionally we did things was by prescriptive formulation. So we'd have prescriptive requirements of strength, prescriptive requirements of cement content. That's what our code, IS 456 for concrete, specifies. And somehow we presume that if I make concrete stronger, it is going to be more durable. That is the underlying assumption. Somehow it is presumed if I add more cement, concrete is more durable. These are all prescriptive measures where you fix numbers and you presume that if you follow the prescription, you will achieve concrete that is stronger, you will have a concrete structure that is more durable. So this is, we have to move away from that thought process and adopt what is known as performance-based design. In performance-based design, we basically express everything in terms of achieving performance criteria. It is left to the producer of the concrete, it is left to the user of the concrete to specify the performance criteria, measure the performance criteria, and assure that that performance is met. Prescriptive measures are not put in place. However you achieve the performance is left to the producer of the concrete, to the user of the concrete. That is performance-based criteria. So now, when it comes to performance-based criteria, we have performance in formation. This is also becoming important. That is where a lot of construction technology is moving. And performance during service life. So performance during service life becomes important. Once I make a structure, it has to last a long time. So performance specifications now. If I talk about performance specifications, we are talking about the material perspective. If I look at it from the material perspective, I have formability, which is one of the important performance specification, placement and speed, how I place my concrete and how fast can I deliver the construction, and of course long-term durability. These are the three essential performance requirements for concrete now. And if you notice the first and second of those, the placement and speed and the formability, these deal with concrete technology, particularly as it relates to fresh concrete. Then there is also the structural performance. Once I put the structure in use, how does it perform against extreme events like seismic wind or any other extreme event that you have? So this is the direction in which we are moving, where we are moving away from prescriptive measures to demanding performance from the material, demanding performance from the structure. So this is the new paradigm, and this is where our new codes are moving. So IS 456 is currently being revised, and the new draft of IS 456 will bring in performance-based specifications, particularly for concrete material design, where we'll insist on performance as a measure. Now, if you look at performance of concrete, I can break it up into two. One is performance of the fresh concrete, performance of hardened concrete. When it comes to performance of fresh concrete, we have issues like pumpability, filling ability, flow of concrete, etc. Performance of hardened concrete deals with strength, long-term durability, etc. So these are broadly the two categories into which we break up the concrete. And just to show you that high-performance placement requirement is indeed a reality, this is a photograph of Burj Khalifa, and here concrete was pumped to a height of 600 meters. Concrete was pumped to a height of more than half a kilometer. Now, if one wraps one's head around this thing, the kind of head that would be required to pump concrete, the pressure head required to lift concrete, which is 2.5 times denser than water to a height of more than half a kilometer. So that requires advances in pumping technology. material, it's not a very friendly material to deal with. It's a very viscous material. It is made up of multiple components. You have to be able to lift all this material under pressure to that height and deliver it at that height. So a lot of advances have already happened. Now we have pumps that are able to deliver concrete at heights of 1 kilometer and higher. We have material compositions that will withstand the pressure, which will go through the pressure system, pumping system, and come out of the nozzle at the other end and allows us to be placed in a form. So all of that has already been done. And if you, just to show you what performance requirements of concrete would look like, this is the One World Trade Center, the tower that replaced the twin towers that collapsed. When they were rebuilding it, they put specifications in place, and those, most of us are familiar with concrete. These are the kind of specifications that are put in place. Concrete had to be placed with less than 236 kgs of cement per cubic meter of concrete. That was a specification that was put in place. Most of you who are familiar with concrete mix design know that we typically use about 300 kgs of cement per cubic meter or more. In fact, most of our concretes, once we go to high-grade concrete, would require 400, 450 kgs of cubic meter. Here, it's almost half of that. That was specified. Now, but there was no let go on the strength. The concrete in columns up to 40 floors had to be 80 to 95 megapascals. So strength was required with less use of cement. There were other performance requirements. The concrete should have the ability to pump for 15 floors for the 95 MPa mix, and it should have the ability to pump at least 40 floors for the 80 MPa mix. So pumping requirements was put in place. So whatever concrete was used should be pumpable. That was a performance requirement placed in concrete. Now, if you notice in this, there is no prescription put in place. The material supplier, it is his or her responsibility to bring this concrete and make sure all these boxes are ticked. Now, they are not insisting that you can use this, or you have to use this, or you have to do that. Nothing is specified. Mixed design is not specified. It's up to the supplier of the concrete. They have to meet these performance requirements. And that is a paradigm shift in the way we will be doing things going forward, where we will insist on performance. We leave it up to the supplier to meet the requirements of our performance needs, not tell him or her how to do things. So that is one of the things that is changing and is already happening. In fact, I had the privilege of working on some of these concrete mixes, testing them while the placement of the raft for this particular structure was taking place. Now, so what are the performance requirements that we are requiring from our concrete? And slowly I'm leading up to the requirements for formation. And what is required is we required a desired flow behavior. This is becoming very important. You already saw in the previous slide, we're talking about pumping. That's a flow behavior. We need concrete to be pumpable for a certain height. Proportion for strength, that is anyway required because we deal with concrete. It is for structural use. Strength becomes an important characteristic. Durability is being prescribed. Low maintenance, that is once it's already in place, if it is durable, it should give me long-lasting performance. All this has to be achieved at low cost. So these are my specifications that are coming up. Now, this is one of the issues that we have, and the way we teach concrete is we teach it as a basic combinatrix of cement, water, and aggregate. That's not going to cut it. If I was to start meeting all these performance requirements, then basic combinatrix of cement, water, and aggregate are not going to cut it. I have to re-look at things, start engineering the material. I need to look at the material, engineer it ground up to meet all these performance requirements. So I really need to revisit my mixed design procedures. And of course, additives come into the picture. Now more and more additives and admixtures are becoming important. Without that, you cannot make concrete to meet all these performance requirements that I've put here. We are starting to look at packing and multi-scale concepts in mixed design. So this is something that we didn't do in a scientific manner. We kind of did it in an ad hoc manner, but this is now coming to the fore. We are bringing these concepts into making our concretes. So today's concretes are very complex. They have a lot of additives in there. They are built with using these concepts of packing and multi-scale concepts. All components are carefully weighed out and they're brought together to make this concrete that delivers on this performance. So it is not a father's concrete anymore. It's not 1:2:4 or 1:3:6 concrete anymore. You cannot achieve these performance requirements with just the basic combinatrix of cement, water, and aggregate. Now, Coming to requirement of admixtures. So I've already laid the groundwork for admixtures. Of course, they are looked upon as performance enablers. So I need to add small quantities of these materials. They are very engineered, complex materials in themselves, which enhance the properties. So I can enhance the fresh property, which brings us into rheology control. So now we are getting into a new domain called rheology. And for mature concrete, I'm looking at things like strength and durability, which brings about a whole bunch of other admixtures that we have, like shrinkage reducing admixtures, super absorbent polymers, and all of these are now being used in concrete for delivering specific improvements in concrete performance. And so what is this admixture or additive? It's basically something that is besides cement, aggregate, and water that's added in a small quantity to bring about a specific improvement in the concrete performance. That is how this is being defined. And if you look at this cartoon here, there's this workman who's basically saying, today's concrete without any admixture basically belongs in a museum. Today, concrete that we are producing, even the RMC that you order, typically is engineered. It has a lot of admixtures mixed in it. Even if it has only one admixture, that admixture itself is a highly engineered, complex material that is added into concrete for specific performance enhancement of concrete. And there's a laundry list of admixtures that has come into the market, and it's ever growing. And there are specific admixtures that help you improve specific properties of concrete. And these basically, the admixtures go into mineral and chemical. Mineral are basically things that mostly are waste products like fly ash, slag, which we've been using. And now we are finding beneficial use of this material in producing high performance, ultra high performance concrete. All of this using waste materials. So I'm able to use the waste of another industry. Fly ash is waste that I get by burning coal. Slag is the waste I get from the steel industry. Use it beneficially in concrete, not just beneficially in concrete, not just get rid of the waste material, but actually help improve the performance of concrete. So now these are really sought after value adds. So not only have we increased the value of the waste material, they've literally disappeared from the market now. We are using up most of these waste materials that you don't find any of these available readily in the market anymore. Then of course with performance there are tests that are required. So now several tests are being standardized so that I can look at not just the short term but also the long term performance. So with that background about performance now, I want to zero in on specific performance aspect of concrete, which is the placement. And we're talking about transporting and placing concrete, and here water, I have segregation. So clearly I need something that starts flowing and that is not reflected in slump. Here is another example of where high slump concrete doesn't cut. This is a board cast in situ pile, and basically it's on a wing and a prayer. So if you have a structure that is sitting on this, well, how safe are you? Because you have no means of looking into the ground. You just trust that you poured concrete and it has filled all the gaps between the reinforcement. So here again, people started realizing that we need a better characterization of flow and be able to make concrete that flows, which is not reflected in slump. Now, where are the challenges that we have? Now, typically, this is what we visualize our flowing concrete to be, coming down a chute, and the minute we look at it, we know that it is actually quite a complex material. It is a complex heterogeneous suspension where we have aggregates, which are the particles of different sizes in a paste, which itself has a very complex rheology. So I'll talk about rheology in the next few slides. So if I have to make this thing flow, I need to look at components separately. So I have the paste, which is basically the fluid component of concrete, and I need to understand what makes that paste flow. What is the flow behavior of that paste? I need to get into rheology, understanding rheology. And then I need to look at the binder, which is the filler, the aggregate, which is filling the space up. I need to understand what determines the content of the paste that is required, for which I need to understand what is the content of aggregate in there and how well it packs. So concepts of packing and the aggregate content become very important in determining what is the paste content that I require. Coming to rheology of paste. So serious concerted efforts on rheology started, I would say, about 30 years ago, when we started realizing we need to understand this paste. How does it flow? Which takes us into the domain of rheology. Now, rheology is basically how fluids flow under applied shear stress. We know that solids and fluids, if we had to distinguish these two materials, solids can take shear stress. If I apply a shear stress, solid can resist shear stress. And we know fluids cannot. So if I apply a shear stress on a fluid, it simply flows. So how does it flow? The description of a fluid flow under an applied shear stress, that is the field of rheology. And chemical engineers have invested a lot of time and effort into understanding rheology because most of the production processes involve moving fluids through pipelines. So they have spent a lot of time, effort, energy understanding the complex flow behavior of fluids. So we started looking at that literature. We started trying to apply that understanding to the cement paste. And we started realizing that we need to understand what would initiate flow, what would cause the cement paste to flow, and how can I sustain the flow. So now terminology like yield stress of a fluid, this is yield stress of a fluid, comes into picture. Yield stress of a fluid, even fluids have a yield stress. So if I take a paste or a suspension, if I try to shear it, it immediately doesn't flow. It takes some effort to get it to flow. There are certain pastes and fluids that behave that way. The effort that is required to initiate flow in these pastes is called its yield stress. This is terminology from rheology. That's when we started understanding that we cannot take the flow behavior of a cement paste for granted. The cement paste, if I was to shear it, if I try to get it to flow, it will not flow initially. It will have some initial resistance. That initial resistance is called the yield stress. Then once it starts flowing, the effort to keep it flowing is called viscosity. So we learned to distinguish these two, and then we learned how to measure these two concepts. So now if I have to make concrete that is self-leveling, I have to cut down its resistance, that initial resistance to flow. It should start flowing the minute there is some gradient, and the effort to keep it flowing, I should also try to keep it to a minimal. These are my requirements. So here is what I have to do for self-leveling. I need a material with low yield stress. The effort that is required to initiate flow has to be low, but I need proper viscosity control. Now viscosity control of the paste comes into picture because if the viscosity is too low, my aggregate will segregate out. If the viscosity is too high, then I have to put in a lot of effort to keep the paste flowing. That means my pumping pressures start going up. So now we got into this domain of rheology control, then water reducers, viscosity modifying admixtures, all these came into market, and we started adding them into concrete in order to control the rheology of the cement paste. Also microfines and packing started playing a role in order to produce this flow behavior. So the minute you lift a slump cone, you see that it completely collapses, it becomes perfectly flat. So we started inventing measures of flow rather than slump. So now when we're talking about self-leveling behavior, we're looking at flow behavior rather than slump behavior. Now, high-range water reducers have been in the market. I think they've become very complex now. If you look at high-range water reducer, basically what it does is it reduces the yield stress of cement paste. That means the effort that is required to produce flow in the cement paste is reduced by adding this high-range water reducer. Just a few drops of high-range water reducer, what we also call super plasticizer, gets the cement paste to flow very rapidly. So you see just a few drops when this is a concrete with a low water to cement ratio which has a slump. Add a little bit of super plasticizer, suddenly you get a flow out of it. This is just another demonstration of that. Cement paste, low water to cement ratio, it's not going to flow out of the cup. You add a few drops of super plasticizer, you reduce the resistance to flow, it starts flowing. And the water demand for now producing flow decreases. But if you look at the super plasticizers, these are highly engineered compounds today. They are organic compounds typically, very, very engineered. And most of these typically are like these comb polymers. They're engineered that the comb polymer has a spine with these teeth sticking out. These adhere themselves to the cement particles. By steric hindrances, they'll produce dispersion of the cement particles. Once the cement particles are dispersed in water, it basically starts flowing. But a lot of effort goes into, and a lot of research has gone into producing different types of these polymers that will basically help us reduce the water demand for flow and get cement paste to flow easily. The next thing is this viscosity modifying admixture. It's another admixture that we need for viscosity control. So basically this increases the viscosity of water, but it does more than that. It actually enhances the ability of cement paste to retain its constituents in suspension. Because I have aggregate sitting in a fluid medium of paste. Now if I start loosening it up, it will tend to cause the aggregate to segregate out. So this is one of those admixtures that helps me do that. It increases the cohesiveness of the paste. It makes the paste more cohesive. And again, these are very engineered molecules that are used. A lot of research goes into it. So these are molecules that basically are highly intertwined chains of chain molecules, which if you shear them, they break up. And then once they're at rest, they again link up and then give you this cohesiveness. So they basically give you this cohesiveness without influencing much of flow. So using this arsenal of these additives, packing concepts, we were able to come up with SEC, and now self-compacting, self-consolidating material, which is self-leveling, it's now become more of science than art. So now we have proper ways of designing concrete mixes that are self-leveling. But of course, we realized that the self-compacting concretes or self-consolidating concretes typically have higher fines, they have smaller aggregate size, and we have lower coarse aggregate content. So if you look at the flow behavior, the yield stress versus viscosity, the normal concrete is that darker shade ellipse. The SEC typically tends to have a much lower yield stress, which means much lower resistance to flow, but it has a higher viscosity. So the pumping pressure is slightly higher. So the effort to pump it is higher, but then once I place it somewhere, because its ability to resist shear stress is very low, it flows by itself and fills the whole form. And this is the same pre-stressed girders which are cast with SEC. You can see the beautiful finish that you get. This is concrete that is placed without any vibration. It fills the form, it fills all the gaps, goes between the reinforcement and compacts properly. Now at IIT Hyderabad, I was entrusted the responsibility of building a brand new campus. So this was the time when SEC was still, people were hesitant to adopt it in India. So we saw an opportunity to use this material so that we would become the test bed to demonstrate the use of SEC. So on our campus, we developed several SEC mixes of different grades of concrete using these concepts. And I just want to demonstrate to you, if this video works, this is the SEC that we've used in our campus. This is about 10 years old. And you can see that concrete basically comes flowing like water. It fills the form without the requirement for compaction. In fact, if you just wait for a minute, you'll see that you need very few workers. There's no requirement for vibration. And the video is stuck actually. It actually fills the whole form without the requirement for vibration. Now, we did something more than that. Now, this is the mix design that we used in our campus in IIT Hyderabad. This is our M35 mix design of SEC. We were able to cheat. Now, there was a coded requirement that says that you cannot use more than 35% fly ash in concrete. But to make SEC, I require fines. So I was able to use fly ash and count it towards fines and pack more fly ash into my concrete. So we've made concrete with 50, 60, even 70% fly ash in it, and make concrete meet all the strength requirements, all the performance requirements, just by working around the system. So I was able to meet the performance requirements by circumventing the prescriptive rules that were in place, without violating any of these rules, by just being creative the way that we account for the fines in there. We developed a procedure for actually measuring the performance. So the efficiency factor is something that we developed, understanding the thermodynamics of the system, and we were consistently able to develop concrete. So here I'm just showing you strength that we got. This is from about close to 600 samples of concrete that we tested from concrete that was placed in different places, different buildings, and the average strength of this concrete was 50 or 51 megapascal when it was designed for 35 megapascal. So we did not compromise the strength. We used a lot more waste material like fly ash in there, delivered concrete that had self-leveling ability. And this is basically the campus. Most of our buildings are form finish concrete. We've not used any paint or plaster, and basically we are able to deliver beautiful surface finish of concrete, form finish, using this SCC material. And to date, we've done about close to 30 lakh square feet, or almost 3 million square feet of constructed space using this SCC, form finish concrete. Now coming to the next thing in rheology control. So we're talking about rheology control. How do you manipulate the flow of concrete? We looked at one example, that is a self-leveling example, where concrete levels by itself, flows like water. The other one, now we're getting into something called shape retention. Can I make concrete that retains its shape? So if I put concrete in a certain shape, it should retain its shape by itself without the requirement of formwork. So that is shape retention. And the best example that one can think of is toothpaste. So when I actually squeeze the toothpaste, it flows, that is flow under pressure, it comes out and it keeps its shape. It basically keeps the shape of the nozzle that has been used to extrude basically. So that is what I would want from my concrete. Can I engineer concrete mixes that have shape retention? That means now I again have to think about rheology control. I have to manipulate the flow behavior so that it flows under pressure, then it comes out, it keeps the shape that it has of the nozzle out of which it has been extruded. Examples abound. We have the zero slump concrete that is used in pavements, and this is the machine that is used for essentially an extrusion process where concrete comes out, and concrete is being, the concrete pavement is being cast, extruded out as it comes out. Concrete is basically comes out, it's dropped in the hopper, it's vibrated, screeded, put in place, and the machine moves forward. There's no formwork you see, and this is very stiff concrete that is able to retain its shape as it's pushed out of the nozzle. Rheology control for shape retention. Hollow core slabs, the way they are made, very stiff mix. It comes out of the, it's essentially put in place with the hollow cutouts, and the concrete has to keep its shape. It has to keep its shape so that those circular cavities do not collapse. This is again possible through shape retention, but of course, we now need to start talking about microfines, retarders, and water reducers used in proper proportions to get this rheological behavior. The next step in the evolution of all of this is extrusion-based 3D printing. Now, 3D printing, there are different ways of the ways that we can print a 3D structure. The one that we are using the most in civil engineering is extrusion-based 3D printing. And the way it works is that you take a structure, you discretize it, you break it up into layers, and then you build the structure one layer at a time. You basically deposit one layer at a time and build the whole structure up. So the whole structure is built one layer at a time. Now, what is the requirement of such a structure? Sorry, before I talk about this, these are the different delivery systems that we have. So usually you have a robotic arm. You can control the movement of the robotic arm. You have material, which is concrete, that is pressured. It comes out of the nozzle, and then once it comes out of the nozzle, it has to keep its shape. So that means concrete should be able to flow under pressure. As I force it through the system, it has to come out of the nozzle and keep its shape. The deposit systems, they basically vary. You have the robotic arm system, you have the gantry system, and then you have the crane-based system. Different systems have been developed, but all of these have been adopted from manufacturing sector. Manufacturing industry has been using additive manufacturing for a longer time. We've just scaled it up because our scales are much larger. So delivery systems, like I said, have been adopted for 3D concrete printing, extrusion-based concrete printing. These have been adopted from what is used in manufacturing. But development of the ink, as they call it. The ink is the material that we use in printing. So simplest example is we use laser printers now without batting an eyelid. We all expect it to perform. Basically, the way it works is a crude form of printing where ink is deposited, except in the case of this, it's a two-dimensional deposition of ink. Now, if we extend it in the third dimension, that becomes 3D printing. So here, I need that ink, and that ink in our case is concrete. And I have to develop concrete, which is my ink, to be used in these printing systems that will deliver this performance. What is the added dimension I need here? The added dimension I need is now concrete should be able to flow under pressure. It should be able to keep its shape as it comes out of the nozzle. And it should develop what is known as buildability. That is, once I deposit one layer, the nozzle comes around and starts depositing the second layer. And that happens in a matter of few seconds. So that means whatever material I have deposited should internally develop a structure that can take on the weight of additional layers. And this has to happen before the material sets. So it has to be independent of setting, because if setting starts to happen, it will start setting in the nozzle and I cannot extrude it. So this process has to be tailored in such a way that if I pressure the material, it flows, comes out of the nozzle, keeps its shape, and allows me to build by adding the weight of additional layers on top. So this is a really complex rheological problem. And in addition to controlling the rheology for shape retention, allowing material to be printed or pumped, I now have to engineer what is known as buildability. The material should develop a structure inside it so that it can take the weight of additional layers. And this has to be done before the chemical reactions that produce setting take place. So this is what is required for 3D concrete printing. And a lot of research, a lot of us are currently working on this development of the ink. And this is the famous triad of concrete printing. The three things that we have to worry about. I need a material that can be pumped. I need a material that can keep its shape after it comes out of the nozzle. And I need a material that's buildable. All three of these have to be, all these three boxes have to be ticked. And for all these three boxes, I need to control specific aspects of rheology of the cement paste. Now, this brings an additional, in addition to yield stress and viscosity, another material parameter now enters into the picture. This is called thixotropy. And thixotropy is basically what is shown in the cartoon here. So you see a material that starts off like a square, so that is not something that's going to roll easily. The minute I put it on a slope, it basically reduces the resistance by turning into a sphere, comes on the other side, and then immediately becomes like a square again, which basically is the shape that can take stress very readily. So this is what I need to engineer with concrete. That is, by itself, it will have some resistance to flow. The minute I pressurize it, it will start flowing. But the minute it comes to rest, it's come out of the nozzle, it immediately goes back to the stiff behavior. So I need now to make this material with this kind of behavior. That's easier said than done, but that is what we are working on. So I need a material that is pumpable with buildability. That means the material should pass through a nozzle, retain its shape, and it should develop an internal structure very rapidly so that it can take on the weight of additional material, additional layers on top. So thixotropy is basically all about building the internal structure in material, and here we are basically starting to bring in materials like clays. In fact, we find that clays, which are troublesome to the geotechnical engineers, are our best friends when it comes to thixotropy. So Mont-Millenite clay, which most geotechnical engineers hate because it has expansive properties, is our best friend when it comes to engineering thixotropy. So, and then of course we also have to manipulate the paste content in the system to be able to achieve this, and with this then we can start developing the ink And now a lot of inks, people have developed concretes that are printable by carefully playing with the rheology of the cement paste, looking at microfines and packing of the aggregate, and now we are able to achieve this buildability where we can stack layers, build a structure one layer at a time. A short video about form-free construction here. This is basically the structure that was built. This is one of the earliest structures that is built. This is in Singapore, where they basically constructed an entire structure one layer at a time. So this is the photograph that I showed you with the twisted column that comes from that particular this thing. So now we have moved further along where we have print systems, inks that are available that allow us to do this. But there's of course one big challenge that still remains, and that is to incorporate reinforcement in here. And even here we are getting creative with the use of fibers. So we are now starting to incorporate fibers in the material in the form of internal reinforcement rather than depend upon external reinforcement using steel rebars. And of course, a lot of experimentation is going on how to co-print steel and concrete. So that is also an option that is being looked at. What is the current state of practice with 3D concrete printing? Most of it is, some of it is done on site. You bring a printer like what you see here, you print a whole structure, or off-site printing where you print elements, bring them onto the site and integrate them. So that sort of becomes like precast concrete applications. Currently, it's still limited to niche applications. We're not even in a position yet to seriously challenge precast construction either. We have been very actively involved in 3D concrete printing. So we've actually taken up an off-site printing of a 3D concrete structure. You see that there. It's a ground-based structure of about 350 SFT, which is printed, assembled, and you see the reinforcement. So we brought in reinforced elements, integrated those with the printed elements, and we've delivered a structure. But there's also a very good opportunity available with this 3D concrete printing, and that is lean construction. I can place material where it is required. So this is a typical beam. If I load it, you see the stress contours. It typically forms an arch. Force flows along an arch, and you have a tension tie. The arch is what carries compression, and you have tension that is carried by reinforcement. So I can shape optimize it, and we've shape optimized it, and we've actually printed a bridge which is about 8 meters by shape optimization, which has a weight which is almost 1/10 of the bridge, which would of a solid bridge of the same span. So that is what we've been able to achieve through this 3D concrete printing. But there are still some challenges. First one, of course, is linking the material property with the structural property. This material has directional behavior. So now we need to get into composite behavior to be able to do the scale link up of linking the material performance with the structural performance. And the last thing I would like to talk about is about active rheology control. So everything we've done so far is passive rheology control. We add things, we mix things, and hope it flows the way we want. But can I do something that actually control the flow behavior? And that is the next thing that we are getting into, where we start looking at things like magnetic intervention. So you have these fluids called magnetorheological fluids, which behave differently depending upon the magnetic field that's applied. So these fluids will behave like solids when you start applying a magnetic field. If you remove the magnetic field, it starts flowing. And these fluids are used in a lot of our automobile components. There are a lot of the magnetorheological fluids that are used. Now, can I use these in concrete? So with the application of magnetic field, I'll be able to manipulate the flow behavior of concrete. So that is the next thing that we're working on, is not limiting ourselves to adding something and hoping we get the behavior, but using active control using magnetic fields applied to concrete with the use of these magnetorheological fluids. So finally, I'd like to conclude saying that there are challenges. We are looking at processing the material so that it delivers the performance. Now, one of the biggest challenges with any new emerging technology is cost. It is, normally we are very hesitant to adopt it because it will be expensive. And unless there is a scale up, when the production goes much larger, the costs don't break even. So a lot of these new technologies are on the cusp of being adopted, so right now they're quite expensive. A lot of these are sold like black boxes. So people who develop a lot of this technology will have you buy it like a black box. They will not disclose what is there. A lot of it is proprietary technology. So you get into a lot of patenting regimes and all these other complications with the adoption of this technology. Chemistry and material science becomes very, very important. We really need to get to the science of the material, which means unlocking the chemistry and understanding the material science, understanding, borrowing from other domains of science. Scale up. A lot of times things work beautifully in the lab. We take it to the field. The minute we try to scale up, it just falls flat. So we really have to work scale up, and that's where, as academicians, I think we fail miserably. We don't think of scale ups. We're always thinking small scale. So we, I think, need to work with the industry to look at scale ups for some of this new technology. Government, biggest hurdle because of legislation, because codes have not kept pace with the new developments of technology. And there are new binders that are coming because production of cement is going to become a problem, so we're bringing in alternate binders. And they don't behave the same way as cements. So if I want to now make concrete flow the way I want with this new binders that are coming into the market, the LC3 cements or the alkali activated binders, I have to reinvent the whole wheel again, try to understand how they flow and how I manipulate the flow. So with that, and of course, whatever decision I take has to be based on a cost to benefit ratio. I cannot look at it as a cost that I'm putting in today, because that will be expensive. Some of this new technology is expensive, but it delivers a longer span performance. And so if I now evaluate the cost over the span of the structure, it becomes cheaper. So I need to look at reevaluating the cost, not as the input cost, but cost over the span, life cycle costing. And that is what I need to do in order to bring in some of this new technology into practical use. So with that, I'd like to thank you for your attention. Hopefully I've kept you entertained. Thank you.
So thank you so much, Professor Subramanian. The American Concrete Institute had to put a provocative topic like, it's not your father's concrete anymore. But then over here, I think without that kind of a controversial topic itself, I could see all of them keenly listening to Professor and his very interesting presentation. Once again, let us give a big round of applause for the wonderful presentation that Professor Subramanian has delivered. Now, as a small token of our love, our appreciation for you coming all the way from Hyderabad and presenting a topic over here, we would like to present a small memento. And to do the honors of presenting the memento, I invite on stage Dr. Anil Joseph, our vibrant chairman of ICI Cochin, and Engineer Punnos John, the Zonal Head Technical of Ultratech Cement Limited. So on behalf of ICI Kochi and Ultratech Cement, here is a small token of our respect, our appreciation to Professor KVL Subramanian from IIT Hyderabad. Thank you so much, Professor. Here is Engineer Punnos adorning the Pannada. And our chairman, Dr. Anil Joseph, handing over the memento. Once again, from the bottom of our hearts, on behalf of ICI Kochi and Ultratech Cement, thank you so much, Professor Subramanian, for delivering that excellent presentation. So once again, thanking you so much, Professor. And now, ladies and gentlemen, before we move on to the awards, can we close this laptop now? Yes. Okay. So before we move on to the awards, there is a very important part that we need to do, and that is introducing you to all the eminent jury for taking their time out to shortlist our best entries. And ladies and gentlemen, here is presenting our jury members of ICI Ultratech Awards 2022. Those, ladies and gentlemen, are the jury members of ICI Ultratech Awards I request Dr. Elson John, the Vice Chairman of ICI Cochin, and Engineer Jayashankar, the Head BPD, UBS and Digital Initiative of Ultratech Cement, to kindly come on stage. Dr. Elson John and Engineer Jayashankar. Now, ladies and gentlemen, let us welcome our jury members with a big round of applause. Architect Niranjan Das Sharma, Architect C.P. Balamurugan, Engineer Jolly Verghese, Dr. Deepa Balakrishnan, Engineer Abhilash Joy, Engineer Jitin Sudhakrishnan, Dr. Anil Joseph, and Engineer Sajid Bhaskar, the eminent jury members of ICI Ultratech Awards 2022. It takes a lot of time, a lot of patience to select the finalists, select the winners from so many entries, hundreds of entries. Requesting Dr. Elson John and Engineer Jayashankar to adorn the Ponnada and present the memento to our eminent jury members. The 8-member jury team of ICI Ultratech Awards 2022 being honored for their time, their expert opinions, their knowledge. Our traditional Ponnada and a memento to all our jury members. Now a group photo with all our jury members. Thank you so much to our eminent panel. Once again, our heartfelt gratitude to all the jury members of ICI Ultratech Awards 2022. And now, ladies and gentlemen, it is time to move on to the award ceremony, the ICI Ultratech Awards 2022. Are you ready? Shall we move on? Yes? Okay. So, the first category of awards for this evening is the Outstanding Concrete Engineer Award. The first category of awards at ICI Ultratech Awards 2022 is the Outstanding Concrete Engineer Award, as you can see on the screen. And the winner is Engineer Shelly S. Fernandez. Here is Engineer Shelly S. Fernandez, the Outstanding Concrete Engineer. I request Professor KVL Subramanian, Engineer Punnos P. John, and Dr. Anil Joseph to come over to the dais. And I request our chairman to be on the dais for the entire time of the award ceremony, being the chairman of ICI Kochi. Ladies and gentlemen, with a huge round of applause, the Outstanding Concrete Engineer Award goes to Engineer Shelly S. Fernandez, requesting Engineer Shelly's family to also come on stage. Engineer Shelly's family, I think his wife is here, requesting you to also accompany him on stage. It is a really proud moment. Here is the better half of Engineer Shelly S. Fernandez, also accompanying our award winner on stage. Hearty congratulations to Engineer Shelley S. Fernandez, the Outstanding Concrete Engineer Award at ICI Ultratech. Thank you so much, Professor Subramanian and Engineer Punnus, for handing over the awards, requesting Dr. Anil Joseph to remain on stage. The next category of awards, ladies and gentlemen, it's the Outstanding Young Concrete Engineer Award. That is the Outstanding Concrete Engineer Award in the Young Members category. As we will be able to see on screen, the second category of awards that we are giving over this evening is the Outstanding Young Concrete Engineer Award, and the winner is Dr. Niven Philip. Dr. Niven Philip is the winner of this award, requesting Mr. Ani George, the Regional Head Marketing, to kindly come over to the dais. Dr. Niven Philip, the recipient of the Outstanding Young Concrete Engineer Award at ICI Ultratech Awards 2022. Hearty congratulations, Dr. Niven Philip, for receiving the Outstanding Young Concrete Engineer Award. And thanks to Mr. Ani George, our Regional Head Marketing of Ultratech Cement, for handing over the award. The next category of awards, ladies and gentlemen, is the Outstanding Concrete Structure in the category of Infrastructure Bridges. Yes, so the next category of awards is the Outstanding Concrete Structure in the category of Infrastructure Bridges, and we have a few finalists for these awards after we will be announcing the winner. And the finalists are yes, those were the finalists for the Outstanding Concrete Structure in the category of Infrastructure Bridges. And the winner is, any guesses from the audience? Yes? Valiyarikil Bridge, Alapura is the winner of the Outstanding Concrete Structure in the category of Infrastructure Bridges. I request Dr. Elson John, the Vice Chairman, and Engineer Jayashankar, the Head of BPD, UBS and Digital Initiatives at Ultratech Cement, to kindly come on stage to hand over the awards. Now inviting the recipients of the award, the owner of the Valiyarikil Bridge, Alapura, Kerala Public Works Department, the structural consultant, Sri Giri Consultant, the project management consultant, Professor Dr. P.K. Arvindan from Sri Giri Consultant, and the contractor is Uralungal Labour Contract Cooperative Society Limited, requesting the representatives from these organizations to kindly come on stage to receive the award for the Outstanding Concrete Structure in the category of Infrastructure Bridges, and the award going to the prestigious Valiyarikil Bridge, Alapura. Hearty congratulations. The project management consultant, Professor Dr. P.K. Arvindan, passed away, so his image is shown on screen. Our fond memories go with Professor Dr. P.K. Arvindan from Sri Giri Consultant. Here is Dr. Elson John and Engineer Jayashankar honoring the winners of the Outstanding Concrete Structure in the category of Infrastructure Bridges. The Kerala Public Works Department, the owner of this project. Sri Giri Consultant, the structural consultants. and the project management consultants, Professor Dr. P.K. Aravindan. And the contractor is Uralungal Labour Contract Cooperative Society Limited, ULCCS. Applause is only coming from the front tables. Esteemed audience sitting in the back may also appreciate our award recipients. Hearty congratulations to the team behind Vallieri Kiel Bridge, Alapura. Thank you to Dr. Elson John and Engineer Jayashankar as well. Now we have a jury appreciation award in the same category, that is for the outstanding concrete structure in the category of infrastructure bridges, and the jury appreciation award goes to Limited Use Subway, Edapalli Southern Railway. Yes, we have a jury appreciation award for the outstanding concrete structure in the category of infrastructure bridges. Requesting Dr. Job Thomas, the Secretary of ICI Kochi, and Engineer Sajid Bhaskar, the Regional Head Technical of Ultratech Cement Limited, to kindly come on stage to hand over the awards, and requesting the representatives from Limited Use Subway Edapalli from Southern Railway to kindly come on stage. The owner of this prestigious project is Southern Railway. The engineer is Engineer Nitin Verghese, and the contractor is CX Verghese. Let us give the winners a big round of applause. Hearty congratulations to Limited Use Subway Edapalli, Southern Railway. Jury Appreciation Award for the outstanding concrete structure in the category of infrastructure bridges. Here is Dr. Job Thomas adorning the Ponada, and Engineer Sajid Bhaskar handing over the memento to the winners of the Jury Appreciation Award. Hearty congratulations, Southern Railway, Engineer Nitin Verghese, Contractor CX Verghese, the Limited Use Subway Edapalli. Thank you so much. Now the next category of awards, ladies and gentlemen, is for the outstanding concrete structure in the category of residential apartments. Yes, the next category of awards is the outstanding concrete structure in the category of residential apartments, and the finalists are saw 4 finalists. Any guesses from the audience? Any names? Okay, so announcing the winner of the outstanding concrete structure in the category of residential apartments is Asset Rangoli. Hearty congratulations. Requesting Engineer Shaiju Nair, the Treasurer of ICI Kochi, and Mr. Rajkumar Pandey, the Head of Kochi Bulk Terminal, to kindly come on stage to hand over the awards. The owner, Asset Homes Private Limited, Engineer Vidya Sagar, the Architect Vaishak Joseph, and the contractor, Asset Homes Private Limited, are requested to come on stage to receive the awards. Hearty congratulations to the team behind Asset Rangoli. Here is Engineer Shaiju Nair and Mr. Rajkumar Pandey honoring the winners, the award recipients of Team Asset Rangoli, the owner, Asset Homes Private Limited, the engineer Vidya Sagar, architect Vaishak Joseph, and contractor, once again, Asset Homes Private Limited. Once again, let us give a big round of applause to the team behind Asset Rangoli, receiving the Outstanding Concrete Structure Award in the category of residential apartments. Hearty congratulations. Thank you so much, Engineer Shaiju Nair and Mr. Rajkumar Pandey, for handing over the awards. Now, we have a Jury Appreciation Award in this category as well. That is the Outstanding Concrete Structure in the category of residential apartments, and the Jury Appreciation Award goes to Ananta Living Luxury Retirement Apartment, requesting Engineer M.A. Joseph, the immediate past chairman of ICI Cochin, and Engineer Abhilash Joy, the secretary of Grace Kerala, to kindly come on stage to hand over the Jury Appreciation Award to the team behind Ananta Living, inviting the owner, Mr. K. Rajan, the Engineer Santosh, Architect K. A. Rajesh, and contractor Nitin Rajan. Hearty congratulations on receiving the Jury Appreciation Award for the Outstanding Concrete Structure in the category of residential apartments. Ananta Living, let us give them a big round of applause. Mr. K. Rajan, the proud owner, Engineer Santosh, Architect K. A. Rajesh, and contractor Nitin Rajan. Moment for the photo. Once again, hearty congratulations to the team behind Ananta Living for receiving the Jury Appreciation Award for the Outstanding Concrete Structure in the category of residential apartments. Thank you, Engineer M.A. Joseph and Engineer Abhilash Joy, for handing over the awards. The next category of awards, ladies and gentlemen, is the Outstanding Concrete Structure in the commercial category. So, the Outstanding Concrete Structure category commercial, and the finalists are really tough competition going on in every category, 3 to 4 finalists. And the award goes to Kerala Startup Mission Digital Hub Ernakulam. Hearty congratulations. requesting Architect Gopakumar, the Executive Member of ICI Kochi Center, and Architect Niranjan Das Sharma, representing IIA, to present the awards to the winners. Indian Institute of Architects, Architect Niranjan Das Sharma and Architect Gopakumar, the Executive Member of ICI Kochi. Now inviting the proud team behind the Kerala Startup Mission Digital Hub Ernakulam, the owner, Kerala Startup Mission, the engineer, Kerala State IT Infrastructure Limited, the architect, C.R. Narayana Rao Consultants Private Limited, and the contractor, Uralungal Labour Contract Cooperative Society. Once again, requesting the entire team behind the Digital Hub of Kerala Startup Mission to kindly come on stage. Let us give them a big round of applause, ladies and gentlemen. Outstanding concrete structure in the commercial category. Kerala Startup Mission Digital Hub Ernakulam. Here is Architect Gopakumar and Architect Niranjan Das Sharma honoring the winners of the Outstanding Concrete Structure Award in the commercial category. Kerala Startup Mission is the owner, Kerala State IT Infrastructure Limited, the engineers, C.R. Narayana Rao, the architects, and ULCCS is the contractor. Here is the team behind the Kerala Startup Mission Digital Hub Ernakulam, recipient of the Outstanding Concrete Structure Award in the category of Commercial Buildings. Hearty congratulations once again, proud moment and a beautiful photo. Thanks to Architect Gopakumar and Architect Niranjan Das Sharma for handing over the awards. We have a Jury Appreciation Award in this category as well, and I had heard this team giving a big round of applause when their name was mentioned when the finalists were written. And the Jury Appreciation Award goes to Qualcrete, requesting Dr. Lati Karthi, Executive Member of ICI Cochin Center, and Engineer Anil Kumar, ILS District President, to kindly come on stage. And now requesting the team behind Qualcrete to kindly come forward. I think they're a very enthusiastic team over there. The owner, Sunny Davis, the structural consultant and contractor, Engineer Pradeep Alapat, the architect, Architect Shamraj, and Architect Shreyas Murli. Ladies and gentlemen, let us give a big round of applause to the team behind Qualcrete that received the Jury Appreciation Award for the Outstanding Concrete Structure in the Commercial category. Sunny Davis, the owner of Qualcrete, Engineer Pradeep Alapat, the structural consultant and contractor, and Architect Shamraj and Architect Shreyas Murli. Dr. Lati Karthi and Engineer Anil Kumar, awarding the winners, honoring the team behind Qualcrete. Once again, let us give a nice round of applause to the team behind Concrete, receiving the Jury Appreciation Award for the Outstanding Concrete Structure in the commercial category. Hearty congratulations once again, and thanks to Dr. Lati Karthi and Engineer Anil Kumar for handing over the awards. Now, ladies and gentlemen, we are going to take a small break from the award ceremony. So, thanking our chairman for being patient enough for giving away all the awards for all the categories. Ladies and gentlemen, we all know that it is actually an honor to be associating with a very good brand like Ultratech for giving away these awards, for being a part of this evening. You're well aware that the brand Ultratech is the country's #1 and most recommended cement brand. It is the largest manufacturer of grey cement, ready-mix concrete and white cement in India, and one of the leading cement producers around the world. It is the only cement company outside China to have more than 100 million ton capacity within a single country. So it is an honor to invite a representative from this esteemed organization, Mr. Ani George, the Regional Head Marketing of Ultratech Cement Limited, to set forth the presentation on India's #1 cement. Ladies and gentlemen, please put your hands together and welcome Mr. Ani George, the Regional Head Marketing of Ultratech Cement, to deliver a presentation on Ultratech.
Thank you very much, Anita, for the brief introduction and also for the power pack comparing. It's my privilege to present Ultratech Cement to you once again. Almost she has said a lot about Ultratech, but still I'll try to tell you more about Ultratech Cement. Though initially Sajid Bhaskar had come and told me that you have to skip few slides, but I'll try to show the entire slides, but I'll be a bit faster, Sajid. Ultratech Cement Limited is, as you all know, is India's #1 cement company, and sorry, I skipped. We are a $60 billion corporation. We are one of the Fortune 500 in the Fortune 500 league. We are operating in 6 countries, 6 continents, and in almost 36 countries across the world. Almost 50% of the group's revenue comes from abroad, and we have almost 120,000 employees all over from almost 100 nationalities. And we were awarded the AON Best Employer Award way back, that is 4 years back in 2018, and we were one of the best employers again declared by Forbes. Aditya Birla, we are in the Grasim division. There are a lot of verticals, a lot of divisions of Aditya Birla. Aditya Birla Grasim is one of them. We are the second largest VSF, that is the viscose staple fiber manufacturers globally. We are #1 chloralkali company in the company. With regards to fashion, Aditya Birla Fashions, some of the top brands you may be aware of, like Van Heusen, Lee, Louis Philippe, Arrow, all these brands belong to us. Even Pantaloons comes under the Aditya Birla banner. And we are the telephone, the Vodafone Idea is a part of the Aditya Birla group. In the carbon black segment, we are world #2. And in Hindalco, the aluminum rolling mill, aluminum rolling sheets and all that, we are #1 in the world. So a lot of things are there. Building a sustainable future, the vision of Ultratech Cement, the vision of the company is to be the leader in building solutions. The mission of the company is to deliver superior value to stakeholders on the 4 pillars of innovation, sustainability, customer centricity, and team empowerment. Ultratech Cement has its footprint almost all over India. We have got 23 integrated units all across India. We have 27 grinding units, 8 bulk packaging terminals, 1 white cement and 1 putty unit, 5 jetties, even one of the bulk packing terminals is here in Cochin, from where we all get the cement. Like Professor Subramanian said, that in future, by I think 2050, that's what he mentioned, we will be requiring almost 750 million tons is what the capacity he said. So Ultratech Cement is progressing towards that. We started off 40 years back, that is in 1983, with 1 million ton capacity. Today, I'm proud to tell that we are almost having 131.25 million ton capacity, and we are inching towards 159.25 million tons by 2025. Ultratech has moved from a product to a solution-based company. Like, for example, you can see we have got Ultratech Cement, we have got RMC, we have got Birla White, we have got the Ultratech Building Solutions, wherein under one roof you get all the products that is available for building materials. We have the Building Product Division, the BPD, and then the latest in the offering that we have is UTech. Ultratech RMC, as I mentioned, we have got a widespread presence of Ultratech RMC all over the country. It's available even in Kerala. We have got 6 plants spread across the state. Birla White, as you all are aware of Birla White, we have got Birla White Cement, and then the fragrance putty, Birla BioShield putty, waterproof putty. All these things are also available through Aditya Birla Group. Then, as I mentioned earlier, the Ultratech Building Solution, this is a one-stop building solution for the retail customer. Here, what we have done is we have tied up with various companies, our allied, whom we call as our allied partners, wherein under one roof you will get all the construction material that is required, like for example, Birla White, Astral Pipes, Havels, Supreme, Legrand, Sera Sanitary Ware, Syntex. All these products are available under one roof. Then the Ultratech Building Product Divisions, the products that are there, the plasters and the dry mix mortars, the plasters and mortars, adhesives and sealants, flooring material, repair and rehabilitation works. Under the waterproofing, we have the liquid waterproofing and cementitious waterproofing products available for your construction needs. This, as I mentioned earlier, UTech, this is the latest thing that we have to offer to all our esteemed customers, engineers, contractors, architects and all, wherein it's a phygital connect, it's a platform. All you need to do is download the app, and the customers, the IHB, the individual house builders and all, they can see what all construction support is required. Everything, anything and everything that is required is available in the palm top. These are some of the prestigious projects that Ultratech has been tied up with. We have supplied almost 100% cement to this to the Sardar Vallabhbhai Patel statue at Gujarat. We were the lead suppliers of T2 terminal at airport Bangalore. The Atal Tunnel, Himachal Pradesh, wherein almost 86,000 tons of cement was used here. The Narendra Modi Stadium at Motera, Gandhinagar, Gujarat, 100% Ultratech cement was used here. This stadium, as you all know, has a capacity of almost 1 lakh people at a time. And I think next week there will be a match. All our products are green certified. Moving ahead towards this, Ultratech is moving towards the sustainable features. These are some of the sustainable features that the company is deploying. We have got 436 megawatt of green power. The total energy consumption is almost 17.64. We are a very water positive company. That is, we return almost 4 times of water that we use, that is 3 times water positive, and almost we are zero water discharging company. So there are a lot of things, but due to paucity of time, I'll move forward. Ultratech, as you all know, you can, with regards to cement, they say you can change anything in your home, but never its cement. So Ultratech Cement, we request you to continue your support by using more and more of Ultratech Cement. And if you have any queries, any questions, we'll be happy to take that. But we'll park those questions post the session. We'll have those discussions. Whatever queries you want, we'll be happy to answer. And there are the ready-mix concrete displays are out there. Our building material products, all those things are kept outside. You can please have a look. Thank you so much.
Yes. Sure.
Today is the 4th death anniversary of Professor P.K. Aravindan, and he's one of the best structural engineers we have seen in the entire country. And I request all of you to stand up for a minute to pray for his departed soul. Thank you. A guru who taught us that if you are arguing on technical ground, even you can argue with God. He was that person who used to tell us, if you are arguing on technical ground, even you can argue with God. So may his soul rest in peace.
Thank you, Dr. Anil. As you said, may his soul rest in peace. And Mr. Ani, thank you so much for that excellent presentation on Ultratech. It makes us all even more proud to associate with such a reputed brand, hearing about Aditya Birla and Ultratech Cements. Thank you so much once again. Now, ladies and gentlemen, shall we move on to the next category of awards? Yes? Okay. So, the next category of awards is for the best built houses in the districts of Thrissur, Palakkad, Kottayam, Idukki, Ernakulam and Alappuzha. So we are going to start with Palakkad district. So our next award is for the best built house in the district of Palakkad. Yes, ICI Ultratech Awards 2022 for the best built house in Palakkad, and the finalists are beautiful houses, tough competitions, but only one winner, and that winner is the Box House. Hearty congratulations to the team behind the Box House, requesting engineer Babu Verghese, executive member ICI, and engineer George Palal, representing Builders Association of India, to kindly come on stage to hand over the awards, and inviting the team behind the beautiful house, the Box House, the owner Mr. Muhammad Riyaz, architect Anas Muttunni and architect Shamim Siraj, the engineer Jishad, and contractor Mansoor Ali. Requesting the team behind the Box House, the best built house in Palakkad district, to kindly come on stage. The proud owner, Mr. Muhammad Riyaz, architects Anas Muttunni and architect Shamim Siraj, engineer Jishad, and contractor Mansoor Ali. Here is engineer Babu Verghese and engineer George Palal handing over the award to the winners, of the best built house of Palakkad, the Box House. Hearty congratulations to the team behind the Box House. And we have our youngest recipient also standing on stage, receiving the award. What a proud moment. Once again, hearty congratulations to the Box House, the best built house from Palakkad district. Now moving on to the next category of awards, that is the best built house in the district of Thrissur. Ladies and gentlemen, the best built house in the district of Thrissur, and the finalists are quite many finalists for the best built house in Thrissur district, and the award goes to Celandine. I hope I'm pronouncing it right. Celandine, Celandine. Requesting Engineer Liji Anna Matthew, Executive Member, and Professor Glory Joseph from CUSAT to kindly come on stage to hand over the awards. Requesting the owner of this beautiful house, Mr. Jixon, the architect, Architect Shyam Raj, and Architect Amal Raj C, the engineer and contractor, Engineer Nandahari, to kindly come on stage. Hearty congratulations. Hearty congratulations to the team behind the beautiful house, Celandine from Thrissur district. The owner, Mr. Jixon, Architect Shyam Raj and Architect Amal Raj, and the engineer and contractor, Engineer Nandahari. Here is Engineer Liji Anna Matthew and Professor Glory Joseph awarding the winners of the best built house in Thrissur district. Now let's take a group photo for the best built house of Thrissur district. Celandine, the owner Mr. Jixon, Architect Shyam Raj and Architect Amal Raj, and Engineer Nandahari. Hearty congratulations. And thanks to Engineer Liji Anna Matthew and Professor Glory Joseph for handing over the awards. Next category of awards is for the best built house in Ernakulam district. Best built house in Ernakulam district is the next category of awards at the ICI Ultratech Award 2022. And the finalists are Those were the finalists for the best built house in Ernakulam district. And the award goes to Pradesh residents. Hearty congratulations. Requesting Engineer Sajid JP, the executive member of ICI Kochi, and Engineer Jude Anthony, representing Structural Engineers Association, to hand over the awards. Requesting the proud owner of Pradesh residence, Mr. Pradesh PK, Architect Sebastian Jose, Engineer Shukur, and Contractor Toji Matthew to kindly come on stage. Pradesh residents, the best built house of Ernakulam district. The proud owners, Mr. Pradesh BK and family, hearty congratulations. Architect Sebastian Jose. Engineer Shukur. I think the applause can keep coming. Let us have some energy for our award function at ICI Ultratech Awards. Engineer Shukur and the contractor, Engineer Toji Matthew, receiving the award for the best built house of Ernakulam district, Pradesh residents. A group photo. Once again, congratulations to the team behind Pradesh residents for receiving the best built house of Ernakulam district, and thanks to Engineer Sajid JP and Engineer Jude Anthony for handing over the awards. Next category of awards is for the best built house of Idukki district. ICI Ultratech Awards 2022 for the best built house of Idukki district, and the finalists are were the finalists of the best built house of Idukki district. Requesting, before that I have to announce the winner. Yes, and the winner is Somi's residents. Hearty congratulations to the team behind Somi's residents. Requesting Engineer Reggie Zakaria, the executive member of ICI Kochi, and Engineer Jolly Verghese, representing Association of Construction Engineers, to kindly come on stage. And now inviting the team behind Somi's residence, the owner, Mr. Somi Thomas, and the architect, Architect Deepas Thomas, and Architect Chinnu S. Joseph, to receive the award for the best built house of Idukki district. Yes. Somi's residents receiving the best built house of Idukki district. Mr. Somi Thomas, the owner, and Architect Deepak Thomas, and Architect Chinnu S. Joseph. Hearty congratulations. Best built house of Idukki district, Somi's residents. Thank you, Engineer Reggie Zakaria and Engineer Jolly Verghese, for handing over the awards. And we have two more districts left. Next is for Kottayam district, the best built house in the district of Kottayam. The ICI Ultratech Awards for the best built house in the district of Kottayam. And ladies and gentlemen, the finalists are yes, those were the finalists, and the winner for the best built house in Kottayam district goes to Pulikil residents. Hearty congratulations. Requesting Engineer AVS Chakravarti, Executive Member of ICI Kochi, and Engineer Mohan Kumar Rao, the past Vice Chairman of ICI Kochi, to kindly come on stage to present the award to the winners, and inviting the proud owners of Pulikil residents, the owner Mr. Babu, and the architect Deepak Thomas, and architect Chinnu Joseph once again. കോട്ടയത്തും ഇടുക്കിയിലും ഈ യങ് ആർക്കിടെക്ട്സ് സ്ഥാപിച്ചു കഴിഞ്ഞിരിക്കുകയാണ്. Architect Deepak Thomas and architect Chinnu S. Joseph once again receiving the awards for the best built house in Kottayam district, and that is Pulikil residents. Hearty congratulations to this young architect couple. Ladies and gentlemen, the best built house of Kottayam district, Pulikil residents. Thank you, Engineer AVS Chakravarti and Engineer Mohan Kumar Rao, for handing over the awards. And the final award in this category, that is the best built house in the district of, which district is left? Alappuzha. Best built house in the district of Alappuzha is the next ICI Ultratech Award 2022 that we are going to hand over. Best built house in the district of Alappuzha, and the finalists are those were the finalists, and the winner of the best built house in the district of Alappuzha is Pulimutil House. Hearty congratulations. Requesting Engineer Jinu Samuel, the Executive Member of ICI Kochi, and Engineer Ranjit Peter, the past Secretary of ICI Kochi, to kindly come on stage to hand over the award, and inviting the proud owners of Pulimutil House, Tini Thomas, the Engineer Toby Francis, and the contractor Tony Francis, to kindly come on stage to receive the awards. Hearty congratulations to the team behind Pulimutil House, the best built house of Alappuzha district. Tini Thomas, the proud owner of Pulimutil House. Engineer Toby Francis, and contractor Tony Francis. Ladies and gentlemen, let us give a big round of applause to the best built house of Alappuzha district, Pulimutil House. Hearty congratulations once again. Thank you, Engineer Jinu Samuel and Engineer Ranjit Peter, for handing over the awards. The next set of awards, ladies and gentlemen, we have an overall jury appreciation award, and it is a special category of award called the overall jury appreciation award, and I request Engineer Matthew Sebastian, the treasurer of ICI Calicut, to please come forward to present the award to the winner. And the Special Jury Appreciation Award, overall Jury Appreciation Award, goes to Tirukochi Heritage Hotel. Hearty congratulations to the team behind Tirukochi Heritage Hotel, the owner, Mr. Shajan Anthony, the architect, Architect Dilip CV, the engineer, Engineer KG Paulson, and the structural consultant, Stuba Engineering Consultants Private Limited. Hearty congratulations. Overall Jury Appreciation Award goes to Tirukochi Heritage Hotel, Kochi. Mr. Shajan Anthony, the proud owner of Tirukochi Heritage Hotel, Architect Dilip CV, Engineer KJ Paulson, and Structural Consultant Stuba Engineering Consultants Private Limited. Overall Jury Appreciation Award to Tirukochi Heritage Hotel, Kochi. Hearty congratulations and thanks to Engineer Matthew Sebastian for handing over the awards. The next category of awards, ladies and gentlemen, is for the Best Student Chapter Award under the Kochi Center. Yes, so the next category of awards at ICI Ultratech Cement Ultratech Awards 2022 is for the Best Student Chapter under Kochi Center, and the recipient of this, we have finalists. The finalists for this award are yes, those were the finalists for the Best Student Chapter, and this is a very important award for the youth, encouraging the youth to come forward. And the award goes to Albertian Institute of Science and Technology, Ernakulam. Hearty congratulations to this proud college. Requesting Engineer Abhilash Joy, Executive Member of ICI Kochi, and Architect C.P. Balamurugan, Senior Architect, PWD Kochi, to please come forward to hand over the award. And here is the student representatives and staff coordinators of Albertian Institute of Science and Technology, Ernakulam. Hearty congratulations. A proud moment for this college. Here are the student representatives and staff coordinators of Albertian Institute of Science and Technology, Ernakulam, receiving the Best Student Chapter Award at ICI Ultratech Awards 2022. Hearty congratulations and thanks to Engineer Abhilash Roy and Architect C.P. Balamurugan for handing over the awards. Ladies and gentlemen, we come to the last and final award of ICI Ultratech Awards, and that is for the outstanding thesis in the field of concrete. Outstanding thesis masters in the field of concrete. And the winner is Engineer Anjana Anand. Hearty congratulations to Engineer Anjana Anand. requesting Engineer Indu Susan Raj, the Executive Member of ICI Cochin, and Professor George Matthew from CUSAT to please come forward to hand over the award to Engineer Anjana Anand, also requesting her guide, Professor Sudha CP, to kindly come on stage. Hearty congratulations, Engineer Anjana, and her eminent guide, Professor Sudha CP, for receiving the award for the outstanding thesis in the field of concrete. A proud moment indeed for Engineer Anjana Anand and her able guide, Professor Sudha CP. Hearty congratulations on receiving the Outstanding Thesis Award in the field of concrete. Thank you, Engineer Indu Susan Raj and Professor George Matthew, for handing over the awards. That, ladies and gentlemen, concludes the award ceremony of ICI Ultratech Awards 2022. Thank you so much to our chairman for standing so sportily from the beginning to the end of this program and handing over all the awards. Before we conclude the function, there is a very important part, that is the vote of thanks. And I invite Dr. Job Thomas, the Secretary of ICI Kochi Center, to deliver the vote of thanks.
A warm good evening to one and all. This function is yet another feather on the cap of ICI Kochi Center. This center is always in the forefront in disseminating knowledge and appreciating outstanding efforts of engineers in the construction industry. I congratulate all the award winners of this evening. It is the dividend of the work that you have carried out in the past. Let me move on to the duty. Today we have heard a wonderful talk on the rheology and the techniques of 3D printing from an eminent speaker, Dr. KVL Subramaniam from IIT Hyderabad. I express sincere gratitude to you, sir, on behalf of ICI Kochi Center. I thank the Ultratech company for being the sponsor and co-organizer of this mega event. I thank Engineer Punus John, Mr. Anil George, Engineer Jayashankar K, Engineer Sajid Bhaskar, Engineer M.A. Joseph, and other Ultratech officials for their earnest effort to make this event successful. Indian Institute of Architects, Grace, Lunsford, BAI, CREDAI, Structural Engineering Association, Association of Construction Engineers, etc. are the like-minded organizations supported this event. On behalf of ICI Kochi Center, I express sincere gratitude to all associating organizations and member representatives for their valuable suggestions. The participants are the strength of any such events. On behalf of ICI Kochi Center, I thank all the participants of today's function. Nice meeting you all in this evening. The mastermind behind this program is Dr. Anil Joseph, Chairman, ICI Kochi Center. And all executive members of ICI Kochi Center have done a great job today. I thank Anil sir and the team members for arranging this wonderful evening. I thank all jury members for this, for their earnest effort in this evaluating the various awards. I thank Anita, Master of Ceremony today. She made this evening so wonderful. The event management team is MGF. I thank to them for this wonderful arrangement here. There is a special announcement for the student chapter. An industrial visit to Chellanam Harbour will be arranged by ICI Kochi Center, and if the chapter coordinators are available, they can book their date for the visit. Thank you all. Thank you very much.
Thank you so much, Dr. Job Thomas, for that beautiful vote of thanks, making sure to thank each and every person who has been integral for the success of today's award function. Thank you, sir. And once again, thanking each and every person who was here, present over here to make this award function so beautiful and so successful. I have to say that this is the last innings of our ICI Ultratech Awards. We started in this month itself in Calicut, and then we went to Trivandrum, and this is our final stage in Kochi. It takes a lot of planning, a lot of effort to organize this kind of an award function. So we definitely have to give a big round of applause to all the people, the Ultratech team and the ICI team who have been, you know, sleepless nights. Engineer Sajid sir, Engineer Punnos, Mr. Ani George, all these people from the side of Ultratech and all the members from the side of ICI have been working day in and day out to organize such a beautiful event. So hats off to them for their hard work and their effort. And our chairman of ICI Kochi, thank you so much. So enthusiastic, so spirited. And Professor Subramanian, we are ever grateful for you coming all the way from Hyderabad and giving such a wonderful presentation. Once again, thank you so much, ladies and gentlemen. The fellowship counter, most important information, is right behind this venue, outside. And we have 2 food counters outside this venue. So one is right over here, and there is another food counter over there also. And we have stalls from the side of Ultratech. And we also have a VR experience. So all of you make sure to experience virtual reality. There is a stall present over there, quite interesting. So these are the informations I was supposed to convey. I think Engineer Sajid sir, I think that's all the information, right? Yes. Okay. So with this, we come to the end of the ICI Ultratech Awards 2022. Thank you so much, ladies and gentlemen, for being an integral part of it. This is me, Anita, signing off. Thank you so much. Rinesh Narayan on stage, ladies and gentlemen.